Hello and welcome to Lesson 10-2. Today we're going to look at quadratics in standard form, the Part 1 video. So if you think back to section 10-1, we saw that the a value, which a is the coefficient of the x squared term, so we saw that the a value will not only affect the direction of the parabola, but it will also affect the width of the parabola. And when I say direction, I mean whether it's U-shaped or upside down. U-shaped, but it can also affect the width of the parabola. Today, we're going to look at how the b value, which is right here, is going to affect the position of the axis of symmetry and the vertex. So to start out with, we're going to look at the property of graphs of quadratic functions. It says that when you're graphing y equals ax squared plus bx plus c, we can find the line x equals the opposite of b over 2a as the axis of symmetry. So this piece of information right here, x equals the opposite of b over 2a, will find the axis of symmetry, Now the other nice thing that it does is it also finds us the x coordinate of the vertex, So if it finds my x coordinate of the vertex, I can find the y-coordinate by plugging that number back into my function and solving for y. So this is a very, very helpful piece of information when we're trying to plot the point for the vertex. So just to kind of reiterate, I have 3 different graphs here. It does tell us down in these little boxes down here what our axis of symmetry is. But to show you how this works, I'm going to show you, we have the equation for the axis of symmetry as x equals the opposite of b over 2a. And we don't read that as negative b, we do read that as the opposite of b because that tells us that we're going to have to change the sign. So for this first example here, my b value is always the number that is in front of the x term. So that's a positive 2, so I'm going to take and make that the opposite of a positive, which would be a negative 2, and then I'm going to divide that by 2 times the quantity of a, and a is this 2 here. So this is going to give me a negative 2 divided by 2 times 2, which is 4, and if I reduce that, this really gives me a negative 1/2, and you can see that that's exactly what they have right here. So that is my x coordinate of this vertex. So if I wanted to write that, that would be negative 1/2. And then to find the y coordinate, all I would have to do is plug that back into this original equation. So I could say that I have y equals 2 times a negative 1/2 squared plus 2 times a negative 1/2. And if I simplify that, I end up with a negative 1/2. So my coordinate for my vertex then is going to be a negative 1/2, negative 1/2. For my next axis of symmetry, I have x equals, in this case, my b value is 4, and I have to do the opposite of that, so that would be a negative 4, divided by 2 times a, which in this case, a is 2. So I end up with a negative 4 divided by 4, which will give me a negative 1. So my coordinate for this point here is a negative 1, and then the y value, I'm going to just plug this in. I have 2 times a negative 1 squared plus 4 times negative 1, and this is going to give me 2 minus 4, which is a negative 2. So my coordinate point then is negative 1, negative 2, and you can see that my axis of symmetry is also a negative 1. Then for my final graph here, to find my axis of symmetry, my a value is 6, so I have the opposite of that, which is a negative 6, divided by 2 times a, and a is 2. So this is going to give me a negative 6/4, or a negative 3/2. So this coordinate point here is a negative 3/2, and to find my y value for the coordinate point, I'm going to have 2 times a negative 3/2 squared plus 6 times a negative 3/2, and that will give me a negative 4.5. So that will give me a negative 9/2, and you can see that that's approximately what that is. So for example 1, we're going to graph this function. Right away, based on what we talked about yesterday, I have a negative a value, so I know that my graph should be an upside down U. The first thing I'm going to do is I'm going to find the axis of symmetry in the vertex. So I have x equals the opposite of b over 2 times a, which in this case is going to be the opposite of 6 divided by 2 times a, which is a negative 3. This will give me a negative 6 divided by a negative 6, or a positive 1. So my vertex has a coordinate point of 1, and I have to find the y value. So that's found by going negative 3 times 1 squared plus 6 times 1 plus 5. So this is going to give me 8. So my vertex is at the point 1, 8. And that's an important point. My axis of symmetry, so I'm going to put AOS for axis of symmetry, as that x equals 1. This is another important part. So if I go and I plug this in, my axis of symmetry is at x equals 1, which will be this dashed line right here. Axis of symmetry, by the way, are always drawn with a dashed line. My coordinate point for the vertex is 1, 8. And because my lines, I don't have that many going downward, so what I decided to do is I made my x-axis increments of 1, my y-axis I'm going to do in increments of of 2. So if I go and I plot this point, I have 1 and then a positive 8, so that's going to be 2, 4, 6, 8. So 1, 8 is right here. This will be my vertex. And then now what I have to do is I have to make a table to find the rest of my points. So I have x, y, and I'm going to use, I'll go 2, 1, 0, and I know that when x is 1, y is 8, this is my vertex. I always like to have a point on either side of the vertex and 0 for x if I can. So I'll go 2, 1, 0, and then I'll do negative 1 as well. So if I plug in a 2, this is going to give me 5. If I plug a 0 in, I will also get 5. And if I plug a negative 1 in, I'll end up with a negative 4. So if I plot these points here, I have the coordinate point 2, 5, so 2, which will be about here. 1, 8, we've already got plotted. I have the coordinate point 0, 5, which will fall right here, and negative 1, negative 4 is going to be down here. So if we go and we connect our points, you're going to see that we kind of end up with something that looks like this. It is downward facing, which I expected from the beginning, and I'm probably on the right track at this point in time. Now for example 2, it says in professional fireworks, displays, aerial fireworks carry stars upward to ignite, and then they project them into the air. Suppose a particular star is projected from an aerial firework at a starting height of 520 with an upward velocity of 72 feet per second. How long will it take for the star to reach its maximum height, and how far above the ground will it be? Now what did get cut out is in this equation, you should have been given that height was equal to a negative 16t squared plus 72t plus 520. Okay, so the t is our time, the h is our height. So what we're going to look for here is we want to know how long will it take for the star to reach its maximum height. Then we want to know how far up will it be. So we're essentially solving for our h here and our t. Well, our t is really an x, and we can solve for x by using the opposite of b over 2a. So we're going to do the same thing for t. So in this case, I'm going to take the opposite of 72, this is my b value, and divide it by 2 times a, which is going to be my negative 16. So I end up with 72 a negative 72 divided by a negative 32, and that's going to give me about a positive 2.25. And because this is time, it will be seconds. So after 2¼ seconds, the star will be at its greatest height. Now to find the maximum height, what I'm going to do is I'm going to take that 2.25 and I'm going to plug that in for my t value into the equation. So I have negative 16 times 2.25 squared plus 72 times 2.25, and then I'm going to add that to 520. And when I simplify all this down, we end up with roughly 601 feet. So this will be the maximum height that that star will reach. Example 3 is very similar. It says a ball is thrown into the air with an initial upward velocity of 48 feet per second. How many seconds will it reach its max height? So again, if we were given the equation, we should have been told that this was negative 16t squared plus 48t, and then it should have been plus 4 because this was being launched from an initial height of 4 feet. So for how many seconds? That's again solving for our x value, and x is equal to the opposite of b over 2a, or a negative 48 divided by 2 times a negative 16. This gives me a negative 48 divided by a negative 32, and when I simplify that, I end up with 1.5 seconds. Okay, so now I'm going to go and I'm going to look for part B. So this here is A. Part B wants to know what the max height is. So that's my y value, and I'm just going to plug that x value in that I found in for t. Okay, so this gives me negative 16 times 1½ squared plus 48 times 1.5 plus 4. And when we simplify this, we should end up with something close to 40 feet high. And for our last example, it says the total profit made by an engineering firm is given by the function P equals x squared minus 25x plus 5,000. We need to find the minimum profit that is made by the company. Well, the minimum profit is going to be at the vertex, okay? And because this has a positive a value, I know that this graph is going to go something like this. So that means I need to find the vertex right here, and I actually need to find the y value because the P stands for profit. But first I have to find my x value so I can find my y. So x is equal to opposite of b over 2a. And in this case, an opposite of a negative 25 is going to be a positive 25. And we're going to divide that by 2 times 1. So this is really 25 halves, or 12.5. Now to find our p value, or y essentially, we're going to plug in our x, and we have 12.5 squared minus 25 times 12.5 plus 5,000, and this is going to give us our maximum, our minimum profit, or it's going to tell us that the minimum profit is going to be $4,843.75. So this would be the least amount of money that that company or that firm would make. Please let me know if you have any questions. Otherwise, you guys have a great day, and we'll see you in class.